Net Ionic Equation Lab Introduction. And I'm going to go to screen share here, bring up the lab, which you can find in Schoology, and here we go. So it looks like we're going to do experiments A, B, and C. The first one is silver nitrate plus aluminum chloride. And then you're going to get a series of questions where you observe, you do a word equation, and then molecular equations. And ultimately, we're going to get to total ionic equations, net ionic equations, and microscopic observations. So in this video, we're just going to do the first couple points here for all three experiments. Okay, so the first experiment is silver nitrate plus aluminum chloride. The second experiment is going to be silver nitrate plus potassium chromate. And the third experiment is going to be lead nitrate plus potassium iodide. So I'm going to give you a visual of all three of these experiments. And let's go back here. And I'm going to stop my share for a second, get a little bigger screen. Looking back at it, in the first reaction, I have an aqueous solution of silver nitrate, which is pretty much clear. And I have clear aluminum chloride. And that will give me, when I combine them, I already pre-did this, it's kind of a white cloudy precipitate. Reaction B, where I did silver nitrate, which is clear solution. And then I got a clear yellow solution for potassium chromate. I get this kind of this chunky reddish maroon like chunkiness right there, which would be a precipitate. And then the third reaction, I think I took lead nitrate, which is a clear solution, potassium iodide, and when I combine those together, I got a cloudy yellow precipitate right there. Okay, so looking at these things, you know, are these precipitates, they look like they're starting to settle. I can speed up that process and just take these things, put them into a centrifuge, we'll spin them around real quick, and give them a go. And what's going to happen, the heavier solid or precipitate is going to spin, or it's going to be pushed to the outside with more force than the lighter things there. So we're thinking the heavier precipitate will go to the bottom, and then we'd be able to separate these things. All right, I think that's probably good. So we give it a little spin, slowly stop that. And I take a look, and I don't know if you can see that there, but there is, it looks like a clear solution, and then there is a white solid on the bottom right there. Okay, so that's separated out. This was the third reaction. It's clear, but then there's the yellow precipitate on the bottom there. You can see how that separated out completely. And then the third reaction, we have still a yellow solution, but there's that maroon precipitate right there. So it gives you kind of a visual of what's going on. So I think this was actually the first precipitate. Maroon was white. The next one, the second one was actually, for B, was the maroon. And then the third one is the yellow precipitate in the clear solution for experiment C. All right, let's go back and take a look at a couple things for processing this. And I'm going to go back to my screen share, find this here, bring this up, bring a marker, and I'm going to kind of cheat all the way over to the partial key, which is in Schoology. And it says it's a white cloudy precipitate, which it was. And then I had it settle to the bottom here. All right, let's do the word equation for this. Silver nitrate, aluminum chloride. So again, silver nitrate is just a positive and negative ion floating around. Aluminum chloride is a positive, negative ion floating around. So the silver could go with the chloride and the aluminum could go with the nitrate. So we're going to switch places, combine positives and negatives, giving us silver chloride plus aluminum nitrate. Okay, and we're going to go through the molecular equations and balancing and net ionics in the next video. But I just want to know, we had a clear solution here. We had a clear solution here. We definitely saw the white cloudiness. Which one is a precipitate? Is it the silver chloride, or is it the aluminum nitrate, or is it both? One of these two things has to be a precipitate, possibly both. And what we're going to do is look at a solubility table to figure that out. So I'm going to look at some rules for solubility tables, and we have this here. So here are the solubilities of some compounds, okay? And let's see, here's a key phrase. If something is soluble, it dissolves, and it's going to actually be called aqueous. If something is insoluble, it won't dissolve, and we're going to use S. Okay, so S is not for soluble. S is for a solid or a precipitate, or meaning it's insoluble. AQ means it's soluble. So I'm going to look at the, let's see, one of them was the aluminum nitrate. Now I see this rule number 3. It says nitrates, no matter what it's combined with, they're always soluble. So that way I can eliminate aluminum nitrate from being the precipitate. So I can say, hey, aluminum nitrate is going to be, I'm going to put a little bit over here, aqueous for aluminum nitrate. So I can write AQ right here. Otherwise, when I balanced it, I just put that right there. How about silver chloride? It says it's a solid. How do I know that? Well, there's one thing through process of elimination. If there's a precipitate and aluminum nitrate is not the precipitate, then silver chloride has to be the precipitate or the solid. Is there another rule that supports this? Let's take a look. And rule number 5 says Cl minus or Br minus or I minus, Cl minus when combined with silver or lead or mercury or copper is going to be insoluble. With any other cation, it is soluble. So Cl with Ag is insoluble, which means it's a solid or a precipitate. So using that solubility table, I can predict which one, or I can use that to find out which one is the precipitate when I see that happening there. So going back, I said all nitrates are soluble, so my aluminum nitrate is aqueous, my AgCl is insoluble, so that's going to be the precipitate or the solid. And that's how I indicated that right here when I balance this. This is aqueous, it's designated right here. This is solid, it's designated right here. Okay, that is how to use a solubility table. I am going to go and complete this video for questions 3 through 6 in the next sequence. Thank you for watching.